now we want to find them. All right, so the last example I gave you the inverses. So now what we do is we want to be able to find them, their domains, be able to graph them. All right, so given a function is 1 to 1, to algebraically find the rule for the inverse. Remember, what we're literally doing is we're flipping the x and y process. And so that's the very first thing you do, is rewrite the function. So replace the function part with y, right? That's what the function part really represents. F of x is equal to y. Because the next thing you're going to do is you're going to flip the role. So basically, whatever was an x becomes a y, whatever was a y becomes an x. Solve that new equation for y to get it in function notation. Function notation is always y equals something in terms of x, and sometimes that can be the hard part. As soon as you solve for y, you go back and use the function notation. So replace that new y expression with the inverse notation. You can always check your answers, and we will do a second example here where we'll check them. If you're unsure, check them using this property. Right, so I want to do another example of going through that property and checking it, since I've only done one. So a second example, using that, where I plug one function into the composition to check to see if my functions are inverses. Alright, so we'll start with f inverse of x. And again, you have to check both directions. And so f, what we're going to plug inside f, is 2 minus 2x raised to the 1/3. Right, so again, that's going to go in here for the x value. And so when we do that, we get 1 minus 1/2 times 2 minus 2x to the 1/3 raised to the cube. Right, so the cube and the 1/3 undoes one another. And it's going to leave me with 1 minus 1/2. 2 minus 2x. Distribute the negative 1/2. And so 1 minus, well, a negative 1/2 times 2 is going to give me a negative 1. Negative 1/2 times negative 2 is going to give me a positive x. The 1's undo one another and leave me with x. So it does check in that direction. Alright, so that side checks. Now the other way. All of a sudden my cats decided they needed to play. Alright, in the other direction, f inverse of f of x. So again, I'm going to take f of x and plug it in my inverse function. My f of x is 1 minus 1/2 x cubed. It's going to go in here for x. So when I plug it in, 2 minus 2 times, you're plugging that whole thing in there for x, so it's 2 times 1 minus 1/2 x cubed. And then that whole thing still raised to the 1/3 power. So I've got to follow order of operations here. It's a lot of order of operations you have to be careful of. First thing, multiply through by that negative 2. So I'm going to get 2 minus 2. Negative 2 times negative 1/2 comes out positive 1. X cubed. Still raised to the 1/3 power. The 2's cancel each other out, which leaves me with x cubed raised to the 1/3. And then the last thing is the third cancels with the 1/3 and leaves me with x. And so that side checks as well. And so with checking, you do have to be careful with the order of operations. So make sure you know how to plug it in, do the composition, which is why we practiced the composition in the earlier section, was so that we could use it here. That is why we practiced it. So those were, again, how we test it. So 1 to 1, that's the one, excuse me, 1-to-1 process. If a function's not 1 to 1, you can still find an inverse, but you can only find a partial inverse. And so what you have to do, if it's not 1 to 1, so if it's not a 1 to 1 function, you restrict the domain in such a way you force it to be 1 to 1. And there's two ways to go. You either use it where it's increasing or where it's decreasing. My rule of thumb, and for the most part, is we typically use increase. So, but you're not wrong if you do it the other way. But typically we do the increase. So I'm going to stick to doing the increase when we get to these cases. And then after that, once you've restricted the domain where it is 1 to 1, then it's the same process we did before. Write down the function as an equation, flip the variables of x or y, solve so you get your invertible matrix. So again, all of that's the same process that we did earlier. The new part is restricting the domain. Right? Then the check that you've done it right, besides doing the substitution, is the domain of f should be the range of the inverse. The range of f should be the domain of the inverse. Any point on f of x that was AB should be an opposite point be A on its inverse, and it should reflect over the line y equals x. So these are sort of, again, these should all be true. If one of them is not true, then you didn't find the inverse. They should all be true. Alright, so that's the process, and then we'll get into actually doing it in the next video.